Let's talk about long division with polynomials. For us to begin, it will be helpful for us to remember what we did when doing long division in elementary school with numbers. For instance, 25 goes into 527. We don't do the whole thing at once. First, we just say 25 goes into 52 how many times? Well, 25 goes into 52 2 times. Now, once I have that 2 on top, remember that what I'm going to do is to say 2 times 25. Anything that goes on the top, we multiply with the thing that is out in front, our divisor. So 2 times 25 makes 50. Once we have that 50, now we subtract. When we do it with polynomials in a minute, I'll be saying let's change the sign, but what we're doing is to subtract just like with our arithmetic. When we've changed this sign, 52 minus 50 gives me 2. Our next step is to bring the 7 down, and as long as what we've got here is at least as big as what we've got there, we can divide again. 25 goes into 27 one time. Anything that goes on the top now multiplies with our divisor. So 1 times 25 is 25. Let's change the sign again, and 27 minus 25 leaves 2 as a remainder. Now, there were lots of ways in elementary school that we wrote our remainder. One was to put an R with the 2 beside it. Another thing that we could do is to put a decimal and zeros behind it and continue to divide. But the way that's going to be the most important for us as we divide algebraic expressions is to take the remainder and to write it as a fraction over the divisor. So that remainder of 2 over our divisor of 25 is how we can express that remainder. Now that we've seen it with arithmetic, let's look at one that is an algebraic expression to divide. Here, if we are taking x squared plus 3x plus 5 and dividing it by x plus 1, the first thing we need to know is how to set up our division problem. The stuff that is in the denominator of the fraction, that's our divisor. So we put it on the outside of our division box. The stuff that is the numerator goes on the inside of our division box. So now we're ready to try to divide. Just like with arithmetic, I don't want to try to divide the whole thing at once. I just want to go one little piece at a time. I'm going to take the first thing here and divide it by the first thing that's there. So we're going to take x squared and we're going to divide it by x. If you divide x squared by x, remember, keep the base, subtract the exponents, so our result here is just an x. X squared divided by x goes x times. Let's take that x and let's put it up on the top. Now, just like with arithmetic, anything that goes on the top is now going to multiply with what is in front, our divisor. So x times x makes x squared, and x times 1 makes x. Just like we did with arithmetic, we now need to subtract that bottom line. But instead of calling it subtracting, I'm going to say, let's change the signs. When we change the signs, I'm going to put the new sign in parentheses so that I can keep track of what sign is the new one. Let's change each of these signs, making that a negative, making this a negative. Now, if we've done our division right, the first part should always go away. Back here on the back, 3x minus x gives me 2x. And just like with arithmetic, let's bring down that plus 5 that's on the back. So now I'm ready to try to divide again. As long as what is here has at least the same degree as what is there, I can divide them again. Both of these have a degree of 1. The exponent understood is a 1, so we can divide this again. Let's take 2x and divide that by x. That's the first thing here divided by the first thing there. Well, when we do that, our x's are going to cancel and we're left here with just a 2. So 2x divided by x gives me 2. That's what's going to go on the top. 2 is a positive 2, so let's put plus 2 between our terms in our quotient. Now, whatever goes on top, let's take that and multiply with what's out in front. 2 times x made 2x. 2 times 1 made 2. Just like we've been doing, now I'll subtract, changing both of these signs. As we change the signs, putting the new sign in parentheses, if we've done it right, the first part's going to go away. 2x minus 2x, it's gone. Here, 5 minus 2 gives me 3. Now this 3 is going to be our remainder. We can't divide again because the degree of this constant value is 0, which is lower than the degree of our divisor. So there's no more dividing that I can do, and 3 is a remainder. How we'll write our answer when we have that remainder of 3? We'll take the quotient, what was on top of our box, and write it first, x plus 2. Then we'll always put a plus sign next to separate the constant value from the fraction that is going to be behind it. No matter what the sign of our remainder is, always stick a plus sign there. Finally, let's take our remainder and put it over our original divisor, which was x plus 1. And this is how we should express our answer. This part was our quotient, our remainder over our original divisor. Here is a little bit harder one. X cubed plus 8 that we're dividing by x plus 2. As before, we need to set up our division with the denominator as our divisor on the outside of our division box and the numerator on the inside of our division box. Now, as I look at this one, I notice that we're missing some terms up there on the top. We have an x cubed, but there's no x squared, there's no x, and then here is our constant value of 8. To help me with my division, to help me keep things spaced out, I'm going to put some placeholders in to account for those missing terms. Here is our x cubed. Let's put in 0x squared. 0 times anything is 0, so adding 0x squared in didn't change our problem any. Let's do the same thing by putting 0x in as well. Now, as we did before, let's take one little piece at a time and try to divide. Let's take the first thing here divided by the first thing there. So if I take x cubed and I divide it by x, the first thing here divided by the first thing there, remember I'll keep my base and subtract the exponents. 3 minus 1 is 2. So x cubed divided by x, it goes x squared times. That x squared we're going to put up here as our quotient above our division symbol. Just like before, anything that goes on top multiplies with the things out in front. So x squared times x is x cubed. X squared times 2 is 2x squared. Once we've multiplied, now let's change every sign, subtracting. So change the sign here and change the sign there, putting them in parentheses so that you can remember what your new sign is. If you've done it right, the first part always goes away. Here in the middle, 0x squared minus 2x squared is negative 2x squared, and I'm going to bring down 0x the next term. So now I'm ready to try to divide again. The first thing here divided by the first thing there. So let's take minus 2x squared and let's divide that by x. Well, there's nothing to divide the negative 2 by, so we know that's going to be part of what we have left here. X squared over x, that'll leave just an x. So minus 2x is the next thing to go on top. Just like we've always done, minus 2x times the stuff out in front. Minus 2x times x is minus 2x squared. Minus 2x times 2 is minus 4x. Let's change our signs. This time the things that we've got are negatives, so as I change the signs, both parts here are going to end up being positive. If we've done it right, remember the first part always goes away. In the middle part back here, 0x plus 4x gives me 4x. And I'm going to bring down plus 8, the only thing that's remaining back there. Now I've still got the same degree here that I've got there, so I can divide this one more time. Let's take 4x, the first thing here, and let's divide it by x, the first thing there. The x's are going to cancel, and it goes 4 times, so it's a plus 4 that we need at the back. 4 times these things makes 4x plus 8. Change the signs. If you've done it right, the first part goes away. And for this particular problem, there was no remainder back on the back. So this time, with no remainder, our quotient, our answer, is x squared minus 2x plus 4.